In the video on updating with for each in a procedure, we saw a case in which we needed to modify the value of the primary key of a record, for which we had to create a new one with the new key value and delete the old one. And we did this by selecting the record in question, creating a new one with new, and immediately executing the delete command to delete the record of the for each in which we were positioned. This is how deletion will be in general. Using for each to choose a record and executing delete to delete it. Let's study the details of the deletion process. Let's remember the transactions that we have been using to study the insertion and update of the database through procedures. Here we had city tour, where we could specify the attractions to be visited on the current tour. For example, at runtime, we had this tour of Paris, which would visit the Louvre Museum and Eiffel Tower attractions. In addition, we had the transaction that records the attractions. And we've entered this error rule to prevent the deletion of an attraction with an entered name. So, let's see that if we try to delete the Eiffel Tower attraction through the transaction, we will not be allowed to do so. Now, what happens if we try to delete it through a procedure? We know that this attraction, Eiffel Tower, is part of a city tour, and that it also has a name assigned to it, which is precisely Eiffel Tower. So, will it allow us to eliminate it? If we think about everything we've seen so far regarding the database update commands through procedures, we can say, yes, we will be able to delete the attraction because no programmatic referential integrity checks are performed. In other words, it will not check that there is no city tour that's referencing the attraction to be deleted. And in addition, no rules are executed for the transaction associated with the table from which a record is being deleted. So if we go to GeneXus, we see that we programmed this button that invokes this procedure that runs through the attractions with a for each filtering by the name Eiffel Tower, and for the records found, in this case it'll be only one, it deletes them with the delete command. If we run it, the program fails. Why? For the same reason we've seen before. The delete operation does not check referential integrity, but the database does it by default, and we're not catching the exception it throws. So, if we want to eliminate that attraction, we should first eliminate it from all the city tours where it's included. In this way. We run it, as an obvious observation, the delete command only deletes the record of the base table of the for each in which we're positioned. It doesn't delete records from the extended table. In this sense, it works as the new command. And another thing that we've already emphasized many times, but is important to emphasize again, the delete command can only be used within a for each and in a procedure. We could not have programmed the deletion directly within the event, for example. This is unlike what happens when updating through a business component. Lastly, in this procedure, we're deleting 2 records. When is this operation committed in the database? The same happens as we saw with new and update with for each. If the commit on exit property is left with its default value, which is yes, since GeneXus realizes that you want to perform a deletion on the database, it automatically adds a commit command at the end of the procedure source. And that's why the navigation list shows a warning to indicate this, so that we know that even if we have not explicitly specified a commit, GeneXus will add it. Of course, we could program a commit after every for each, or even after every delete, because in this case, the for each will retrieve a single record, but there could be several records. In short, to delete records specifically through a procedure, we have the delete command that must be used within the for each command. The deletion will be of the record of the for each base table in which it's positioned in each iteration. For deletion, there's no point in performing a key uniqueness check because nothing is being inserted or updated. And as we saw with insertion and update, the delete operation does not programmatically perform any referential integrity check. Again, this is for performance reasons. However, databases in general do make it, unless we turn off that feature. Therefore, if we don't turn it off and integrity fails, they will throw an exception. Finally, for the record to be committed in the database, in other words, permanently deleted, we must make sure that the commit command is executed. In a procedure, by default, an implicit commit is placed at the end, as long as it's understood that the source is accessing the database somewhere to update it. But we can explicitly write commits in the source where it's convenient for us. We will not see it here, but optionally, you can specify a blocking clause, which allows you to make deletions in blocks instead of record by record. That is to say, it'll process records in blocks of n records to reduce the number of accesses and improve performance. For insertions, updates, and deletions, redundancies are not automatically maintained when done procedurally. This is the developer's responsibility to do so. We suggest visiting our wiki for more information. We still have to see a brief comparison between performing the create, update, delete operations in this way, with these procedure-specific commands, or doing it using business components.